Welcome to Ask and Learn.
They want us to figure out how many weighings are needed to find a counterfeit coin among 8 coins. And all they tell us is that counterfeit coin just doesn't weigh the same. And then they want us to describe an algorithm to find the counterfeit coin using this number of weighings. All right. Well, for this, what we're going to do, so we have pretty much two decisions that we can really think about. So we can either have where they're equal for their weighting or they're not equal. So we have two decisions. And then we have 8 of the coins being possible for a fake. So that means we have 8 outcomes. So what we're going to end up with is that our minimum weighings should be, so it's going to be log base of our decisions 2, and then of our outcomes. So this should be 3. So at a minimum, we should have 3 weighings. And now what they want us to do is come up with some kind of algorithm to determine how many weighings we actually will need to do, or an algorithm that'll allow for us to get to this in 3 weighings, no matter what. And they actually talk about this here on page 796. Or actually, let me double check. Yeah, 796. All right, so now our thing is we want to figure out how we can do this though within these minimum of 3 weighings. All right, so let's say we start with, so let's just write this again. So 8, 1 fake, or 1 is fake, I should say. Well, what we can go ahead and do is compare 4 of them. So what I'm going to do, so let's have our little balance scale here. So I'm going to throw coins 1 and 2 here, and then 3 and 4 over here. Well, now we have 2 possible outcomes. We have that 1 2's weight is equal to 3 4's, or we have 1 2's weight is not equal to 3 4. All right, well, let's go with assuming that they're equal for right now. All right, so this implies that 1 2 3 4 are real. So that means either 5, 6, 7, or 8 are fake. One of these will be fake. All right, so since we know 1, 2, 3, 4 are real, why don't we weigh 1, 2 versus 5 and 6? So let's do that. All right, so it doesn't matter which one you choose from 3 and 4. The only thing that matters is that you choose 2 of those. All right, so we have this though. So again, we have 2 choices. So we could have where 1, 2 is equal to 5, 6. So now this is going to imply that 7 or 8 is fake. So then all we need to do is compare 7 or 8 with any of the other coins. So let's just throw 1 and 7 here. All right, so then we have 2 possibilities. So if 1 is equal to 7, then 8 is fake. But if 1 is not equal to 7, then 7 is fake. And you can see we'll end up with the same process for all of them pretty much. But let's just go ahead and finish though. So let's finish this part of the tree. So over here, we would have 1, 2 is not equal to 5, 6. So that tells us one of these is going to be our fake. All right, so 1 is fake. Well, what we can do in this case is go ahead and Oh, actually, more than just saying one of these is fake, what we should say is that 5 or 6 is fake. Because remember, 1 and 2 in this case are real. So we can just compare 5 with anyone else. So let's just do 1 and 5. And then again, we get two cases. Either 1 is equal to 5, which tells us that 6 is our fake, or we get that 1 is not equal to 5, which tells us 5 is our fake. All right, so at least on this side, you can notice how many weighings have we done. So we did 1, 2, 3, and then this is 3 also. So it looks like what it is going to be good so far. And now what about over here? So the case of 1, 2 not equal to 3, 4. So this should give us, so if 1 and 2 and 3, 4 are not the same weight, well, let's think what we should do. So this implies either 1, 2, 3, or 4 are fake. So why don't we just try weighing 1 and 2. So let's just do 1 and 2. So this gives us two outcomes. So we either have where 1 is equal to 2, which this implies 3 or 4 fake. And then all we need to do in this case is again take one of our possible fakes and weigh it against any of the ones we know are real. So let's just do 1. So we do 1 versus 3. And again, we have two possible outcomes. 1 is equal to 3. So that means 4 is fake, or 1 is not equal to 3, so that means 3 is fake. All right, and then the other case that we had over here was that 1 is not equal to 2, so then that tells us that either, let me draw this a little bit further down, so here. So 1 is not equal to 2. So that means one of these, so 1, 2, is fake. And so now all we need to do is compare any other coins with these. So we'd have 1 here, and then we can do like 3 here. So then we have two choices. So 1 is equal to 3, which means 1 is real, or we have 1 not equal to 3, or sorry, this we weren't saying which one is real, we're saying which one is fake. So this would mean 2 is fake, and then over here, if 1 is not equal to 3, that means 1 is fake. And we can see down here, we get each of our possible outcomes. And no matter how many steps we did this, we were able to reach our final destination in at least 3 weighings. So there are other ways you could do this where you could just do like one coin at a time. So you could do like 1 and 2, and if one of those weighs differently, then you can just weigh it against any of the other ones. So you could possibly do this in 2 weighings, but the maximum cap for that is going to be a lot higher. So in this case, we can always make it so no matter what, we do this in 3 weighings without having to do all the guessing and checking. So this is the algorithm that I would say would be best for this. And then you can just kind of write this up more in words if this diagram doesn't really suit you. But I feel this diagram is a good example of what the algorithm actually is going to be.